Hello everyone, I'm Ratan. This is your third pre-class video on Java. In this small pre-class video, we are going to discuss about OOPS concept in Java. What is an object? What is the requirement of creating an object? How we create an object of a particular class? And what will happen when we create the object of a particular class? So let's get started. So as we are aware of what the procedural programming, that is our C program. So the procedural programming is about what? Writing the procedure or function that perform operation on the data. While object-oriented programming is about creating objects that contains both data and methods operations. In object-oriented programming, we need to find the programming solution in the term of objects. In the term of what? Objects. Now, what is the object? Objects are the real-world entities which can have some state and some behavior. For example, pen, table, watch, computer. These things you can say that the real-time entity are the objects. These objects can be physical, can be logical. So by the help of this object only, we are going to think the solution. So basically in object-oriented programming, we create multiple objects. These objects will gonna collaborate each other. These objects will gonna interact with each other, and they provide the services or the solution to a particular problem. Now we have already seen that what is a class, why we create the class. Now the classes and objects are the two main aspects of the object-oriented programming. Class is a blueprint of an object. We can create multiple objects to a particular class, whereas an object can be defined as an instance of a particular class. An object have an address in the memory label. It occupies some space in the memory. For example, car class can have multiple objects like Creta, Scorpio, Safari, Baleno. So this type of what? These are the objects of the car class. And each object can have its own state and behavior as well. So state and behavior, what is the meaning of that? Data which is present to the object at that particular point of time is known as the state of an object. And behavior of an object, what is that? The methods which are applicable to that object is known as behavior of an object. For example, each car object can have their own state, like model. What is the model number of a particular class? What is the color? What is the price? What is the weight? So these could be what? You can say that they are the state. At that point, whatever the value of this color and price and the model is there is known as a state of that object. And the behavior you can think like that for a particular class: start method, stop method, change gear method could be a behavior of a particular object. So data at that instance of time is known as the state of that object, and methods which is applicable to that object is known as behavior of that object. Now, the next thing is that in object-oriented programming, multiple objects, I just have told that just now I told here, will collaborate each other and provide the solution for a particular problem. Object-oriented programming concept provides following principles to the application development and application maintenance. These are the basic principles of object orientation, like encapsulation, polymorphism, inheritance, abstraction. And those programming languages, they follow these principles, are known as the object-oriented programming language. Java alone is not a only object-oriented programming language. There are multiple programming languages are there, and all those Object-oriented programming languages, they provide what? They implement this principle. Like .NET, we have a .NET, we have a Java, we have a JavaScript even also. Now, before talking about that, how we create the object, let's say that what is the main requirement of creating an object and how we create the object of a particular class, technically how we create that. To understand this concept, we need to know about one concept is there that is called static loading and dynamic loading. Static loading and dynamic loading. To understand that requirement of creating an object, technically how we create the object, why we create the object, we need to know about this concept. What is the meaning of static loading? Static loading is a one type of loading. A block of code would be loaded into the RAM. And before it get executed, it will be loaded into the RAM. Before it is executed. And after being loaded into the RAM, it may or may not be executed. That is known as what? Static loading. That means entire block of code. That means entire your application will be loaded into the RAM. Dynamic loading means what? A block of code will be loaded into the RAM only when it is required to be executed. Not your entire application will be loaded. Only required part will be loaded into the RAM. Our C program follows the static loading, whereas Java follows the dynamic loading. It sounds like cryptic. What is the meaning of static loading and dynamic loading? Let's see that here. To understand this concept very well, I have drawn one diagram and you will understand that. I hope everybody is aware with the IPO model of a computer system. That is input, output, input, process, output. So we give some input instructions to the computer, it will gonna process and then it will give the output. And for that one, we have input device, output device, and processing unit, CPU is there. Now, if I ask you, what will happen? What will happen when we install a particular software? I'm not talking about the Java and all the things. What will happen when we are going to install a particular software? Let's say that I'm going to install a VLC player in my computer. I have a Windows operating system. I'm going to install VLC player. Then what will gonna happen? So first of all, we need to download the exe file from the internet, and then that setup of VLC player we need to download, and then we need to just run this. And it used to ask some instruction. Generally, we do that. What next, finish. We'll do that. While doing next, finish, it used to ask some license agreement, some location where we want to install that particular software. And after that, some configuration, and you'll do the finish, the software will be installed. Now this software will be installed where? The software will be installed in your computer hard disk. Computer hard disk, the software will gonna install. The default location, you might have seen that it is a C program files. In a C drive, program files folder is there, and where in this program files, the folder will be created called, let's say that VLC, and in that folder, this VLC player will be installed. So this is a part of your hard disk. This location is a part of your hard disk, and the software will be installed in your hard disk. Now, after that, what will happen? There are some other things also happen like that. Your desktop shortcut will be created for this VLC player. Then after, in the start menu, the entry of this VLC player will be there. Now imagine in your desktop one VLC player shortcut is created, and you want to launch this. You want to launch this VLC player. Then what will happen? And how will you do that? Simply, we just double click on the desktop icon of this VLC player, and this VLC player will be launched. But what internally happen here? This program is installed in your hard disk. Now let's see that this diagram will gonna help you. So this is your machine where you have installed the VLC player and one desktop icon got created. Once I will do the double click on that, then what will happen? First of all, the software is installed in your hard disk. And you might know that what is a RAM and processor CPU. RAM is what you can say it is a primary memory, and hard disk is your secondary memory. This RAM is your primary memory, and hard disk is your secondary memory. Now, when we double click on this VLC player, what will happen? First of all, this application has to be loaded into the RAM. Has to be loaded into the RAM. Then only it will be available for the CPU. Your application will gonna executed by the CPU, your processor. Until your application is not loaded into the RAM, it will not be available for the CPU for the execution. Any application if you are running, it has to be processed to the CPU. But CPU will collect the data. CPU will gonna run the application from the RAM. That's why we used to take very high RAM in our mobile phone, in our computer. So any application, if you want to execute, that has to be loaded into the RAM, and from the RAM, it has to be executed. Now, what will happen? What will happen in our structured programming language like C and in a static loading? Suppose that you have written a C application. It follows the static loading. In this application, imagine you have taken 100 variables to keep your data. And let's say that you have taken 1,000 methods, 1,000 functions. Imagine it's a very big application and you have taken those many data. Now tomorrow I want to execute among this 1,000 function, I want to execute only one function. One function I want to execute. But what will happen? Even if you want to execute only one function, you have to load. That means your C application will gonna load all the application part inside the RAM. That means all the 100 variable, 1,000 functions, all the part will be loaded. Not only this, your header files and all those files will be loaded into the RAM. And then only one functionality will be executed. This is called what? Static. But in Java, what will happen? Java, we know that first of all, we need to compile a .java file. Let's say that I have a Java file called demo.java. And after compilation, we get demo.class file. This is your source code. And this is your bytecode. This .class file contains the bytecode. Both will be there in your hard disk. Initially, both will be there in the same location, hard disk, where your .java file will be there. There, the .class file also will be generated. Now, what will happen when we are gonna run this Java file? To run the Java file, we generally give the command what? Java and then after demo. To compile the file, we give the command what? Java C and demo.java. So we get the .class file. And to run this one, we give this command. We give the name of your bytecode. What will happen at this moment? At this moment, Java will gonna load only some required part. It will not gonna load all the part of your bytecode. It will gonna load only the required part. It will load only the required part. What is the required part? We are gonna see that. It will not load all the part of your Java application. Now, what is the required part? The required part is what? All the static members. All the static members will be loaded. Static members, that means what? Your static variables. If any variable you have defined as is static, or static methods. If you have defined some methods as a static, static is a keyword. If you place before a particular variable or method, that member will become a static member. So this part will be loaded initially. But those members which are not static, they are non-static members, they will not be loaded. They will not be loaded. Let me show that one example to you. So this is our demo.java file is there. I've created before our first example. And I'm taking one local variable into, let's say that x is equal to 10. And I'm trying to print this value, system.out.println x. And if I compile this file and run the file, let me just do that one, java c demo.java. It will be compiled successfully, and java demo, it will gonna execute successfully. Now, if I take any non-static member inside this application, right now in my application, I have only one member is there. Only one member is there. And that member name is what? Main method. You cannot count this int x10 is also as a member, this line also as a member. No, they are the part of your main method only. So this is the member. Here I have written two statement. It could have 10,000 statement, but still it will be counted as only a single member, main method. They are the these things are the part of your what? Main method. They are the member of your main method. They are not a member of your demo class. Now, if I'm going to take one variable here, let's say that int z is equal to 500. Int z is equal to 500. And now if I'm trying to print this z, trying to print this z, and see that while compilation, I'm going to get a compiled error. And just read the error. It's saying that non-static variable z cannot be referenced from static context. I told that Java follows dynamic loading. It only loads what? The required part. That means the static part. Z is what? Is a non-static member. Non-static member. It initially it will not be loaded into the RAM. But if I make this as a static also, now static part will be loaded initially into the RAM and they will be available for the CPU for the execution. Now if you save this, and there will be no any problem, and you can see here you'll get the output. But if I just remove the static, now this member will become a non-static member, and we cannot access non-static member from the static area. From the static area. So in Java application, we need to observe two things. First, count the members. How many variables and methods are there? How many variables and methods are there? We need to count. We cannot write any executable statement here, system.out.println and something like that. We cannot do this one. This cannot be a member of your class. It is an executable statement. It should be inside a block or inside a method. If you do so here like that, it will give a compile time error. We cannot do that. Even another part, Java does not support nested method. That means we cannot define a method here also. Why? Let's say that I'm defining a method function1. If I try to do so, one function, if I try to define here, it will give a compile time problem. Let me just put here system.out.println. Inside function1 of demo. Now it will give a compile time error. Java does not support nested method definition. What we can do, we can cut it from here. Just put here inside. Demo. We can cut this method from here and we can make this as a member of this class. Like this. Now in this class, if I tell you that how many members are there, so in this class, I have total 3 members are there. One is a Z whose value is 500. One is a function1. Both are non-static. And one is a main method. So we need to observe two things. First, count the members. How many variables and how many methods are there? So how many variable, how many methods are there? This is the first thing. So here one variable and total 2 method is there. One is the fun1 is a one method and main is one another method. After that, second what? Out of this member, how many are static and how many are non-static? Which member is a static member? Which member is a non-static member? How do I know that? The static keyword. The static keyword, if it is placed before a particular method or member, you can say it is a static member. Otherwise, it is a non-static member. So right now, these two members are the non-static. If I place the keyword here is static, then it will become a static member. Otherwise, if I just remove this one, it is a non-static member. Remember, our Java main method is always be a static because it's a required part, and from here the entry of the JVM will start the execution of your application. So if I try to compile this file right now, I will give it will give a problem because I'm trying to access non-static member from the static area. You can think non-static members are the part of hard disk and static members are the part of RAM. Static members are the part of RAM. They are directly available to the CPU, but non-statics will be there in the hard disk. They are not available to the CPU directly. So we need to think static members are the part of RAM, non-static members are the part of hard disk. Since Java follows dynamic loading, it loads only the required part into the RAM at the time of execution, and that required part is nothing but static members. So first of all the static part will be loaded into the RAM, and after that JVM will search the main method in our application. That is public static void main, and start the program execution from the first line of the main method. So what is the flow of execution? First, when you are trying to run the application, it will load all the static member into the RAM. Since main is a static member, it will be loaded. If any other static members are there, that also will be loaded. And from the main method first line, the execution of your application will be started. Non-static members will be there in the hard disk in the form of bytecode. So first load all the static member into the RAM and start the execution from the main method. If main method is not there, we cannot run our file. Yes, we can compile the file, not a problem. We can compile a file. Let's see that. The main method I have deleted. If I try to compile, we can compile a file. We can generate a .class file. But when we try to run the file, it will give a problem here. What is that? Main method not found. Please define the main method as like this. So main method must be there in our application in order to execute a particular Java application. Now, if JVM won't found the main method, it will raise an runtime exception or error, you can say that. From the static method or area, we cannot access the non-static member directly. So if I'm trying to access the non-static member Z from the static area main method, we cannot access this one. It will give a compile time error. So see here, the error is there. Non-static variable Z cannot be referenced from a static context. Now what to do? We have a two solution. In order to access this Z value, in order to print that, we have a two solution. First, you can make this as a static. Now static part will be loaded into the RAM and they are available to the CPU. So static and static both are there, they are shareable, and you can access the value. Compile the file, compile successfully, and run the file. You'll get the output. If I make that, suppose that here lots of variables are there and all variable, if I'm making them as static, then there will be no any difference between our C programming language, static loading and dynamic loading. So we don't make all the members as static. We let them as a non-static. Only the required member, frequently used members, we can make them as a static. The remaining member, let them as a non-static. What we can do at the runtime dynamically, we can load this one in the RAM and we can execute that. Let me repeat once again. We can load the non-static members into the RAM dynamically. In order to load the non-static members in the RAM dynamically, so that they will be available to the CPU, we need to create the object of a class. We need to create the object of a class. So in order to access this Z, what we need to do? We need to instantiate this class. We need to create the object. How we create the object? Take a type demo, which class object you want to create. Take a reference variable of this type. This is a user defined data type. And this is a variable, and assign object. How we create the object? By using new operator. New demo. This is the syntax of creating an object. This is the syntax of creating an object. Once this object is created, all the non-static members will be loaded into the RAM. And now you can happily access this t1.z. Through this, with this reference variable, we can access this Z. So now you can see here, this time it will not give a error. This function is also a non-static function. In order to call this function, what we can do? We have to take the help of this t1 variable. So t1 dot function one. And this function will be called. Now this is the syntax of creating the object. Here new is an operator. What it will gonna do, inside the RAM on a particular area called heap area, it will reserve some memory space, and in that memory space it will load these non-static members. It will gonna load these non-static members, and the address of that memory space will be given to this t1 variable. So here the object is created and that object has all the non-static members loaded, and that object address is assigned to this t1. If I simply print this d1, if I simply print this one, you can see here d1 will gonna print the address. The address of that object will be like this: demo @ and some hash code. You are not gonna get the exact address of a particular object. Internally, it will be gonna map with a particular one number and then hash number, and you are going to get that number. It is not like a pointer here. With the pointer, we can access that particular address where the physically that object is there. We cannot do that. So this is the syntax of creating the object. Now, why we have created the object? What is the requirement of creating the object? If somebody asks, what we can see? What we can say here, we can say to load the non-static member of a class dynamically into the RAM, we need to create the object. And this is the syntax of creating an object. Static members, if they are the static members, they will be directly available to the CPU. We need not create the object. But for the non-static member, we need to create the object. And it will be loaded. And that means all the non-statics are loaded. And with this reference, we can refer the object here. That means any member, any non-static member. So what is the responsibility of new operator? First, it will gonna reserve the memory space inside the heap area of the RAM. In the RAM, there is one special area called heap area where one memory space will be reserved. Load all the non-static members of that class into this area, into this area. And while loading the non-static variable, if the variable is not initialized, then default initialization will be provided by the new operator. What is the meaning of that? Let's say that this variable is not initialized. Then while loading this variable, what it will gonna do, it will gonna give the default value to this variable also. This variable is known as an instance variable. So now if I try to print here d1.z, we are going to get the default value of integer is 0. So here 0. So any data type, the default value will be given. Default value will be provided. This is the way we can create the object of a particular class. And what is the requirement of creating an object? I hope you got the clarity about that, how we create the object. Thank you for watching this video.